it's good to also split your line into so that you can easily be able to read your code. So now that we have that, I will now do function create delivery. Function create delivery. The access modifier will be public, meaning that it can be called outside of this smart contract. And also, I want to set it as payable because the user will be making payment with this particular function. So since the user will be making payment to this particular function, then we can set it as payable. So now that we have been able to set it as payable, then it's important for you to also pass the needed parameters. So what are the needed parameters? Meaning that what are the values you're going to be needing inside this particular function as you implement some instruction in the function. So the first parameters that must be passed with this function is the receiver, and the person receiving this particular parcel. And also I need the person, the pickup date. So when was the parcel picked up? And also I need the distance. Note that we are only specifying that the distance, the pickup dates should be memory. We are defining this as memory because we actually don't want to save the value that is being passed to this particular data, the particular variable. We don't want it to be saved on the blockchain, so we just want it to be maintained in the body of the function. Assuming we want to save it to the blockchain, for example, we might have set it to storage, so it will charge us for the read and writing of the value to the blockchain. But since it will just live for the lifespan of the function, then that is why we just specify it as memory. So now that we have that, let's just clean up, putting it on a separate variable just for make it more readable. Now we are also specifying it as public because we want to be accessible outside of this smart contract. And also, since we are going to be sending payment from one user to the other inside this function, or the user will be making payments, we actually define it as payable. So now this is our function definition. It's now time for us to define the body of the function. The first thing, what you just want to do here is that you want to ensure the price is more than 0, just kind of doing some check and balance in the function. And also you will then go ahead to create the shipment, create a new shipment, after which you will emit the shipment related event. And once you have emitted, then you will increase the counter so that when next you are adding a shipment, it will actually go to the next serial number. Alright, so let's go ahead to do all this one after the other. To ensure that the price is more than 0, all you just need to do is just to require. If you want to check if something is true or not in Solidity, you use the required. So we want to do the message.value is greater than 0. Then we want to tell the user that the amount must be greater than 0. And remember to terminate it with a semicolon. Actually, anytime you define something as required in Solidity, pay attention to this message. Don't forget we talked about three types of variable in Solidity. Types of variables, which is the local variable, the state variable, and also the global variable. So this local variable is actually a variable that is defined within the function, so its scope does not go beyond the function. However, when you have the state variable, it's actually the variable that you define at the contract level. For example, all this variable, this particular variable, this particular variable, this one, they are all state variable because they are defined at the contract level. So if you define a function, you can use the variable. If you define another function, you can use the variable. Let's assume that we define a particular variable inside this particular function. Its usage will only be limited to this function, so it can't be used anything beyond this function. That make it a local variable. And now when we now talk about global variable is the variable that is coming directly from the blockchain itself. A variable that is coming directly from the blockchain itself is called a global variable. For example, this particular variable it's a global variable because it is coming directly from the blockchain itself. And when you see something like this, message.value is just talking about the price or the amount or the fee that is passed, not fee now, but the price, a price tag that is attached when this function was being called. So it checked the price, it checked the amount that is being sent alongside this function, and if it is greater than 0, so what it just wants is that it wants this to be true. If it is true, then we are good. But if it is not true, then it's going to throw this particular error message. So let's assume it is greater than 0, then there's no problem. It will go ahead to execute the other lines of the function. However, if it is false, then it will trigger this error. So when you say require, that means this is actually required for you to go ahead and continue to execute the remaining lines of this code. So now that we have ensured that the price is more than 0, so what we now want to do now is to create a new shipment. And to create a new shipment, you can just check what you define as your shipment here. So we define it as shipment, so I'll just say shipment. Then the current counter of shipments. So let me just come and show you so that you will know that we are not doing any magic here. So the current counter, you can see this is what we are using to count. Initially to be 0, since we are defining it as unsigned integer. So the current counter then it will be equals to this particular structure of shipment, this particular structure. So you want to create a new instance of that structure, and that is what you want to do at this point. So you want to define the seller. Who is the seller? If you want to get, you can just copy all these particular details that you will be needing, so that it will be easier for you, so that you know that we are actually doing something very simple. So the variable, the identifier that we give this entity, which is the seller, we are going to be defining it. And also the logistics provider, we want to add the value for the logistics provider, and also for the receiver. You can see everything is step by step. So then the price, then also the pickup date. Please make sure that whatever the way you have defined your identifier for each attribute of the structure, it must actually be the same. Don't come here and put seller 1. It will give you an error. Make sure that you define it exactly the way you created the structure. So just 2 column here, and also here, and also here, and then here. So we are going to be separating each, just like in JavaScript, comma. When you separate object with comma, then you separate each of them with a comma. Don't worry, we'll define the value for each. Just wanted to see how we build it step by step, so there's no too much magic to hit. So the first value, which is the seller. How do you get the seller? The seller is actually the one that called this function. It is the seller that creates the delivery. So how do we get the seller? Let's just say payable message. Don't forget, message is coming from the blockchain. That make it a global variable. Message of sender. So the person that is currently calling this particular function is actually the seller. So that's the seller calling this. So that's the seller calling the function, and because it's going to be passing some value, we need to define it as payable. So the same thing for the logistics provider. The logistics provider will also be payable. However, we are not sure of the logistics provider that will pick up this parcel, so we can just set it to a non-address, but a type of address, but not any particular address. So how do we do that? We just do address 0. Then also after that, the receiver, don't forget we are passing some values with this function. So the receiver will pass with the function, because when we are creating the delivery, the seller will specify who the receiver is. So we define the receiver. So also the price will be specified by the seller. So that will also be passed with the function when the function is being called. So the price that is being passed with the function, in order to get it, we just use the message of this function dot value that will get the price that is being passed with the function. And also in order to get the pickup date will also be passed. You can see we are passing the pickup date into the function. Then we can also specify that as our pickup date. And to get the distance is also passed to the function. So at the point when we are calling this function, then the distance will also be passed along with it. Now the delivery date. So it does not distance, the delivery date, let's set it to none for now, since we are not sure of what it will be. It is only after the receiver have confirmed the receipt that's when we'll know when it was actually delivered. Because we are going to be getting the value of delivery date, let's still leave it as empty, but we are going to be updating it when the user get the value. Now that we are here, so we can just say status. So what is the current status? At the point of creating the shipment, the current status is created. So you can just say status dot. So if it is pickup dot pickup, if it is delivered dot delivered, but for now status dot was created. So now that you have that, then you can now close that particular semicolon, that particular instance of the structure that you have created for a particular structure. Now that you have created a new shipment, then you can now emit the action that, alright, so I've been able to create a new shipment. So you should just emit the event that allow Solidity to know that this action has been successfully created. So you emit delivery, you emit a function called shipment created, you emit the event shipment created. So what are you going to be passing? You're going to be passing the counter. You're going to be passing the counter. This is the counter here, shipment counter. I just need to go and pick it so that you know that we are not manufacturing it anywhere but inside our code. So message to sender, which should be the seller selling the parcel, and also the price of that parcel. We are going to be getting all from the blockchain, which is why we actually define it as message.value. So having done that, this will emit our shipments created event. So you can just terminate it with a semicolon. So once you have been able to do that, you just increase your shipment counter so that when next you want to create a new shipment, you actually take the next serial number, and once it takes that particular serial number, at the point of creating that shipment, it increases again so that the next one coming again will take an updated value of the shipment counter. So let's just do shipment counter plus plus. When you see shipment counter plus plus, all it's just telling you that it's just the same thing as saying shipment counter is equal to shipment counter plus 1. So that is it. So the same thing when you see shipment counter minus is the same thing as saying shipment counter is equal to shipment counter minus 1. So that is shipment counter for you. Alright, so whether it's plus plus or increment or decrement for you in it's popular like that too in other programming languages apart from Solidity. So now that we have been able to do that, we are done with the create delivery function. Before we